All right, let's learn about virtual functions. To get started, we are going to make a very, very simple example and then go from there. So let's make a new file. It's called main.cpp. I'm sure you can follow that. Make the main function. Again, I hope you are able to do that on your own without having to follow me. I'm also going to include, is it IO stream that they want us to include for, I think so. And then add a hello world just to test if it worked. Let's compile that real quick. Not test, it's called main. All right, compiles, it runs. Great, it says hello world. Now let's make a new class. Since we're talking about virtual functions, and those are used in inheritance and child and parent classes. So first, we're going to make a new class. That's the parent class. And that class is going to be called parent. I know, it's very creative. It's going to have public only one function, and that function is going to be void, which means it doesn't return anything, so we don't need to return anything. It's going to print stuff. And that function is going to be called print stuff because of how awesomely creative we are. In fact, we're going to implement the function right there because making a new header file for this is just too much work. So let's go ahead and print I am a parent in that function. Let's compile it to see if it didn't make any grammar mistakes. Okay. Need a semicolon here. Great. There we go. So now we have a parent. Let's see if the print function works for the parent, just to make sure. We'll make a new parent pointer, call it P, and make it a new parent. And actually, since we're being nice and proper, we're gonna call delete on P, just to make sure that memory is allocated. Sweet. Oh, well, we didn't actually call anything. We didn't call the function. So let's say P print stuff. That's pretty obvious. I'm a parent, says our program, which is great. But now let's have a class, another class that extends parent. We'll call that class child. And the colon means extends all the public functions from parent. That's what the public word means. If you're not familiar with this, you might want to look over Galbraith's videos because he covers actual inheritance. And then we're going to override the function here. We're going to type the same function name. And then we're going to print something else. We're going to say, I am a child. There we go. Okay, now I'm just testing to see if it compiles. Does it compile? Semicolons. There we go. All right. So now we're going to delete this. And we're going to make a new child. Child pointer child equals new child. So we're creating a new instance of one of those. And then we're going to create a new, actually no, we're not. We're just going to we're going to call child print stuff again, just to make sure. It prints, I am a child. Great. So far, there's been nothing really unexpected about what we've done, but let's take a look at something else. Suppose we don't know whether this child whether the object we're creating is actually a child. So actually, let's create a new class again. Like in our classes, we had multiple things for video games, movies, and media, and other kinds of media. So we're going to create another child. I'll call it Sibling, because it's a sibling of the first child. It also extends parent. It also has only one function that it inherits from the parent, because the parent has it. But we're going to change that to print something else. I am a Sibling. I misspelled sibling in the class name. Cool. Semicolon. Cool. He compiles. Alright. So now we'll make also a new sibling. And call print stuff. Oh, forgot to add the pointer. There we go. Alright. So it prints I am a child because first we print the child, and then it prints I am a sibling because there's a sibling. Alright. But just like in media library, let us pretend that we do not know what type the new object we have is. So we only know that it's some kind of media item. In our case, it's some kind of parent. So parent pointer, parent. And first we're going to say the parent is actually a child. And then we're going to call parent print stuff. And then we're going to say the parent is actually the sibling. And then we call print stuff again. Alright. So what do you predict will happen? Think about that for a sec. Alright, we're going to run it. It prints I am a parent twice. This is because regularly the functions by the compiler are resolved when it reads the line. So to clarify, let's say it goes to this line and it sees parent print stuff. Well, it checks what type parent is. So it finds where it's declared and says, oh, parent is actually a parent pointer. So we're going to call the parent's print stuff function because we know for sure that it is a parent, because it says so here. So even though we add a child to it both times, it still prints the parent stuff because it doesn't know whether it is a child or not, because it only knows that parent is actually some kind of parent. There is another way to do it though, and that way is actually virtual functions. So when you add virtual functions, instead of checking what type it is statically, like at compile time, when the compiler looks at code and says, I'll call the parent function, we actually add a secret variable to the object that we're creating that tells the compiler or the program when it executes what type it is and what function should be called. So to do that, we actually have to make all these functions virtual. All this means is that instead of trying to match what function to call at compile time, which is when the program is built, it actually checks what function to call when it runs. So then it knows whether it is a sibling or a child or a parent and then calls the respective function. So if we compile this now, we're actually going to have I am a child and I am a sibling.